It describes the middleware and information services with its logical architectures again and application level event specifications with EPC global network and its information services. The first one is motivation. So the motivations behind radio frequency identification technology is automation and then efficiency, because RFID eliminates the need for manual scanning like barcodes. So it enables fast automatic identification of objects without line of sight. So it saves labor cost and time in industries like retail, logistics and then manufacturing. Second motivation is accuracy and then visibility. It provides real time tracking. The third one is security and then authentication. So RFID tags can carry unique identifiers and even encrypted data and useful in anti-counterfeiting, like example paramedicals and luxury goods in that. So it helps control access to restricted the area devices or vehicles. The fourth motivation align is scalability. It can manage large volumes of tagged items simultaneously. So thanks to anti-collisions protocols also. So it's suited for big supply chains, warehouse, airports and then smart shelves. And the final one is data richness, durability and flexibility, and then integration with IoT and then smart systems. So RFID act as a bridge to IoT. It enables devices, products and then assets to connect to the network. So it plays a key role in smart supply chains, intelligent retail and in industry 4.0. So this is the components of RFID middleware. It's having application level interface, event manager and then reader adapter. So the next one is application level event specification. RFID reads generate large volumes of raw tag data, and it can enterprise applications cannot directly process the such raw data. So to solve this, the EPC Global developed the ALE standard, a middleware interface that filters, aggregates and reports RFID data in standardized way. So, what is the role of ALE, which means it provides a standard API for applications to get only for useful events. So, it hides the complexity of dealing with the different readers, protocols, and duplicate tag reads. And it transforms low level tag reads into high level business events. So finally, ALE is a standard specification developed by EPC Global to process the RFID data. That is, the purpose is to filter, group and then report tag data in a way that is in business applications. Its function is filtering, aggregation, reporting. So the output is standardized in XML event report. But in Savant, it is a middleware system, that is a software component. It is originally proposed by the Auto ID Center. The purpose is to handle the high volume of RFID data flowing from readers before sending into high level systems. So the function is act like a data manager and a traffic controller for EPC data. So it use ALE specification for data processing. It routes data between RFID readers, EPC information services and enterprise applications. So the components of Savant model, it can handle the task like reader coordination, buffering and catching, filtering and aggregation and communication with EPCIS. Event originator in RFID system. So it is the system having the sources that generate RFID related events in a system. They are the first point where RFID tag interactions with environments are detected. So these raw events are then processed by middleware before reaching the enterprise applications. So types of event originator, it includes the RFID readers, RFID sensors, RFID tags and other sensors or devices. So the flow of events from the originator is based on starting from event originator, that is it may be like readers or antennas or sensors, then move on to the middleware, and then move on to the applications. Then comes to when read cycles. So the reader can scan for RFID tags or other physical observations or set as a frequency and demand. So here how the events are originated and then passed through the readers to the ALE servers. It is a client based. So each scan is called the read cycle. Then comes to an event cycle. The event cycle, it is a basic unit of data collections and reporting in the application level events. It just defines when, where, and how RFID data should be collected, processed, and then report. So an event cycle is that time bounded window during which RFID readers captures tag data, which is then filtered and aggregated before being reported. Then comes to when data elements. So the data elements are the units of information is stored or associated with RFID tags and exchanged between readers, middleware, and enterprises applications. So they define what informations an RFID system carries about item, case, pallet, or asset. In EPC global view of data elements having some identification data and business data, and then tag memory banks like that. A reader list. So this reader list in the ALE specifications, which means it is an event cycle specification that can be noted as ECSPEC spec. So it defines what, when, where, and how RFID data should be collected during an event cycle. Applications submit an ECS spec to the ALE middleware to request the tag data. So reader list is a section. It's inside that ECS spec and it specify which readers will be used for tag collection. So without the reader list, ALE would not know from where to collect the data. So its structure is shown here. It's having the individual reader names, logical readers as a groups, and then nested list also. It is the scope of data collections and it allows the flexibility and then improves the controls. Comes to when primary data elements. These are the core information units that make RFID systems it works. It's especially in EPC global architecture. Each diagram it also having electronic product code. It's an main primary data element, and second one is unique identifier for every physical object it can be observed. For example, it have an company phrase, item reference, and then serial numbers also. Then comes to an tag identifier, TID. It's a unique serial number. It's born into the RFID tag microchip, and it can be identifies the type and then origin of the tag chip, and it's used for tag authentication and avoid the cloning. Then comes to an accessing part. It helps to kill the passwords and it can stored in the reserved memory, which means it has an access password and then kill passwords. Then comes to an memory data. Some RFID tags provide users memory for storing application and specific informations. Reader event metadata. It captured the EPC. Whenever a tag is read and certain primary data elements, it's an automatically generated along with EPC. These are all done with the ALE service interface.